Modern households rely on batteries as a background component of daily operation. Vehicles, tools, personal electronics, backup systems, and portable devices all depend on stored electrical energy delivered in standardized formats. These systems are typically engaged only at the point of failure. A battery functions without attention until it no longer does, at which point replacement becomes the default response. This pattern is reinforced by how batteries are distributed and serviced. Most consumer batteries are sold as sealed units with limited visibility into their internal condition. Diagnostics are minimal at the consumer level. When performance degrades, the boundary between weak and non-functional is often unclear, and the decision to replace is made without detailed inspection. As device counts increase, so does the accumulation of partially depleted or discarded batteries. Garages, drawers, and storage areas commonly hold units labeled as dead without a defined process for reassessment. Disposal and replacement remain simpler than evaluation. The effort involved in learning how batteries degrade, how capacity loss occurs, or how recovery might be attempted is externalized. Complexity accumulates not in use, but in waste, cost, and repetition of purchase. Within this system, battery failure is treated as an endpoint rather than a variable state. The infrastructure surrounding batteries supports acquisition and disposal, not intervention. EZ Battery Reconditioning is positioned as an instructional resource rather than a physical tool or device. Structurally, it exists as a digital program composed of written guides and visual diagrams. The material is delivered through downloadable files designed to be accessed on common consumer devices, including computers, tablets, and phones. The product belongs to the category of procedural documentation. Its stated function is to describe methods for interacting with different battery types at a mechanical and chemical level. Rather than supplying replacement components or automated systems, it focuses on step-based processes intended to be carried out manually. The format emphasizes instruction over explanation. The guides are structured to show sequences of actions rather than provide deep theoretical grounding in electrochemistry. Visual aids are used to illustrate physical steps, tool placement, and procedural order. The program does not position itself as a diagnostic instrument, a testing device, or a manufacturing solution. It does not claim to alter battery design, material sourcing, or industry standards. Its scope is limited to interaction with existing batteries already in possession of the user using commonly available supplies. It also does not function as a subscription service, monitoring system, or automated maintenance platform. Engagement occurs only when the material is actively consulted and applied. Interaction with the product is episodic rather than continuous. The material is not designed for daily use, scheduled routines, or ongoing tracking. Access occurs when a specific battery is selected for evaluation or intervention. Time involvement varies by battery type and by the depth of engagement chosen by the user. The guides are structured so that individual procedures can be followed independently rather than as part of a linear curriculum. There is no fixed progression requirement or completion sequence. Repeatability is built into the format. The same instructional material may be referenced multiple times across different batteries of similar type. No consumption or depletion occurs within the product itself. The content remains static unless updated externally. The mechanics assume access to basic tools and a physical workspace suitable for handling batteries. The process depends on user execution rather than automated enforcement. Accuracy, pacing, and adherence to steps are controlled entirely by the individual applying the instructions. The product does not incorporate feedback mechanisms, sensors, or verification systems. Outcomes are not measured or logged within the program. The guides function as reference material rather than interactive software. This format simplifies access to procedural knowledge by consolidating multiple battery types into a single instructional system. It reduces the need to search across fragmented sources or rely on informal advice. By presenting standardized steps, it lowers the initial barrier to attempting battery intervention. At the same time, the format leaves several areas unresolved. It does not determine whether a specific battery is suitable for reconditioning prior to engagement. It does not eliminate the need for judgment during application. Environmental factors, battery history, and condition variability are not actively assessed by the material. The guides do not replace professional diagnostic equipment or industrial processes. They also do not address regulatory considerations related to resale, disposal, or commercial use. The responsibility for interpreting applicability remains with the user. For individuals seeking automated solutions, guaranteed standardization, or externally verified results, the structure may feel incomplete. The program operates entirely at the instructional level, without enforcement or assurance layers. The trade-off inherent in this approach is control versus certainty. The format offers procedural visibility, while leaving execution and evaluation open. Within the broader landscape of battery-related solutions, EZ Battery Reconditioning occupies a space between replacement purchasing and professional servicing. It does not compete directly with manufacturers, retailers, or recycling systems. Instead, it introduces an intermediate layer of engagement that sits before disposal. Compared to technical manuals or academic resources, the material prioritizes accessibility over depth. Compared to tools or services, it offers information without intervention. Its role is informational rather than determinative. Certain details remain inaccessible without direct review of the guides themselves. The exact level of technical specificity, the variation between battery categories, and the extent of procedural differentiation are not fully visible from description alone. The way visual elements are integrated with written steps can only be evaluated through inspection of the material. A complete understanding of how the product operates in practice requires exposure to its internal structure rather than summaries or secondary explanations. The material positions itself as something to be examined rather than concluded. The format remains open-ended by design, leaving its practical implications dependent on use rather than description.